Crash Course Instrumentation, Episode 31, Solder Defects and How to Spot Them. Welcome back to Crash Course Instrumentation. Today we're going deep into the world of soldering failures. Because even if your soldering iron technique is solid, things can still go wrong. And in the world of industrial instrumentation, that means signal drift, intermittent faults, or total loop failure. Let's break down the most common solder defects and how to spot them before they cause problems. 1. Cold solder joint. 1. What it is. A joint where the solder didn't fully melt or bond to the surface. 2. What it looks like. Dull, lumpy, or grainy instead of smooth and shiny. 3. Cause. Insufficient heat, poor contact, or moving the joint while cooling. 4. Fix. Reheat the joint properly and let it cool without disturbance. 2. Fractured joint. 1. What it is. A joint that cracked or partially broke after cooling. 2. What it looks like. Ripples, visible separation, or hairline cracks. 3. Cause. Mechanical stress or movement while cooling. 4. Fix. Reflow the joint and ensure strain relief on wires all components. 3. Non-wetted joint. 1. What it is. Solder hasn't flowed properly onto the surface. 2. What it looks like. Solder is balled up or lifted, not fully covering pad/lead. 3. Cause dirty, oxidized, or poorly prepped surface. 4. Fix. Clean the joint, add flux, and try again. 4. Bridging. 1. What it is. Unintended solder connection between two adjacent pads or pins. 2. What it looks like. Solder blob creating a short. 3. Cause. Too much solder, poor technique, or too large tip. 4. Fix. Use solder wick or a vacuum tool to remove excess. Tombstoning, SMD specific. 1. What it is. One side of an SMD part lifts off the board during soldering. 2. What it looks like. Component standing on end like a tombstone. Will cause uneven heating or poor pad design. 4. Fix. Reflow with proper thermal profile. Use paste evenly. Pro tip. Learn to inspect visually. A good solder joints are smooth, shiny, slightly concave, and fully cover the pad and lead. A magnifying lamp or microscope is a great tool for inspection. Field insight. In analog loops and low-voltage signals, a poor solder joint doesn't just fail, it degrades over time. Resistance goes up, noise creeps in, and troubleshooting becomes a nightmare. Diagnostic strategy. Suspect a solder defect if you have intermittent faults, signal drift, or ground path problems. Always double-check hand-soldered joints during prototyping, installation, and rework. Fun fact. NASA has published entire manuals on what a perfect solder joint looks like and uses X-ray and SEM, scanning electron microscopy, to inspect high-reliability assemblies. Coming up next, we'll explore desoldering and rework techniques to safely fix what you find without damaging the board. If you found this helpful, give us a like and subscribe. Join our Facebook group and share your own soldering wins and fails. Huge thanks to Tony Kuphaldt and the Model project. All this knowledge comes from the open source tutorials at ebiblio.org.